Hi, my name is Ötzi. Welcome to today's video about the chemical element Arsenic As. This is a picture of element arsenic, which has the atomic number 33. It was known for a long time. It was isolated by Albertus Magnus, who was called Albert the Great in 1250. Its name comes from the Middle Persian word Arsenic, which means gold color. In nature, there's only one stable isotope, that's arsenic 75. And there's a gray arsenic, which is the most stable of three allotropes. Allotropes are different forms of the same chemical element. Arsenic sublimes at a temperature of 615 degrees Celsius. This is the nucleosynthesis of the chemical elements, the origin of the elements. Arsenic is here, a member of the pnictogen group, and its origin is from exploding massive stars. This nuclear reaction is called R process. That's the rapid neutron capture process. Arsenic is known to be toxic in high doses. However, it is important for some bacteria species, and its role in the human body is unclear. A concentration of 10 parts per billion in water is tolerable. This is the Chinese leather brake, Aries vitata. This is from Chatswood in Australia, and this plant is known to accumulate arsenic, and it can be used for cleaning of soil. This is the picture of the abundance of the chemical elements in Earth's crust. Arsenic is here. It is number 53. And the concentration is 1.5 parts per million in Earth's crust. These are three examples of arsenic in nature. At the left, that's native arsenic from Almont, France. In the middle, that's arsenopyrite, FeASS, the Yaoshan mine in Hunan in China. And at the right, that's arsenic trisulfide, As2S3. This is another picture of native arsenic. Arsenic is a byproduct of the copper, gold, and cobalt lead mining. It can be isolated by carbothermic reduction of arsenic trioxide with coke. Then you can purify arsenic by making arsenic trichloride, which can be distilled and then reduced with hydrogen. Pure arsenic is needed in the semiconductor industry. The total global arsenic production in 2022 was 61,000 metric tons. Number one producer was Peru, number two China, number three Morocco. Arsenic can be used in the semiconductors industry in two ways. One way is for N-doping of silicon, because arsenic has 5 outer electrons. That's one more than silicon. And the second use is as a semiconductor with gallium, as gallium arsenide, and this gives you faster circuits than circuits with silicon. This is another picture of native arsenic from St. Andreasberg in Germany. Arsenic is also used in alloys, for example brass and ceramics. Arsenic is also used in poultry. For example, as the compound roxazone. This is the structure of this chemical compound. This compound speeds the growth of the chicken and gives its meat a pink color. In traces, it is essential for the methionine metabolism of these animals. But in high concentrations, arsenic is a teratogenic and a carcinogenic element. This is the cycle of arsenic in nature. There are three sources, volcanoes, or industrial processes, or natural fires. The concentration of arsenic in ocean water is 1.7 micrograms per liter. This is a reconstruction in a museum of Ötzi. His body was found by tourists in the Ötztal Alps in 1991. This is the oldest known mummy in Europe. He lived 5,000 years ago, was about 1 meter 60 centimeter high, at a weight of 50 kilograms, and he died at age 45. And in his left shoulder there was an arrowhead. A few things were known about Ötzi. For example, he walked long distances, and he had arsenic and copper particles in his hair. So there was speculation maybe he was a shepherd or a miner. And what was interesting was the quality of his clothes and shoes were very high quality. And another thing that was known about Ötzi, that he was lactose intolerant. This is a picture of Ötzi's copper axe, a reconstruction. It may be used as a tool or as a weapon, or maybe both. This is the compound arsenic trioxide, As2O3. It is known to be toxic. It can be made by oxidation of arsenic minerals, for example, arsenic sulfide plus oxygen makes arsenic trioxide plus sulfur dioxide. This compound can be used as a wood preservative in the glass industry for pesticides and as a leukemia medicine. That's why this arsenic trioxide made it into the list of essential medicines of the World Health Organization. This is a picture of realgar, which is arsenic sulfide. These are crystals from Washington, USA. This compound can be used as a herbicide to kill weeds, and in the leather manufacturing, and as a red paint pigment. Ancient Greeks made fool's blood, which was a poison, out of this compound realgar. And arsenic can be removed with activated carbon. This is a picture of the Marsh test. That's a way to detect arsenic by making the compound arsine, which is arsenic hydride. This test was developed by James Marsh in the year 1836. This is how it works. Arsenic compound is reduced with zinc in the presence of sulfuric acid. That gas compound arsine, zinc sulfate, and water. If arsine is heated, it is decays to arsenic metal, and you get this arsenic mirror. But this test works with other elements too, for example, antimony. The difference is the arsenic mineral is soluble in a solution of ammonia and hydrogen peroxide. That's the difference to antimony. This is another important compound, organic compound, arsphenamine, also known as Salvarsan. Was synthesized by Alfred Bertheim in 1907. It is related to the toxic drug atoxyl. And during that time, there was a systematic test of new compounds for their effectiveness against diseases, for example, syphilis. But this compound, Salvarsan, was difficult to use because it had toxic reaction products with air. That's why another variant was developed in 1912, that was Neo-Salvarsan. The structure at the top, that was believed to be the molecular structure of Salvarsan. But the mass spectrum showed that it's actually a mix of B and C of these two compounds. So arsenic atoms are big. They don't want to make double bonds with each other. They prefer single bonds. That's why you have the mix of these ring structures. And Salvarsan was replaced by penicillin in the 1940s. This is a picture of Orpimet, arsenic sulfide from Twin Creeks mine in Nevada, USA. This is a picture of native arsenic from the Rona mine in the Czech Republic. This is a nice Ötzi monument in Bolzano, Bozen, Italy. And this is a scene of the movie Arsenic And Old Lace from 1944 with the great actor Cary Grant. It is available on archive.org. I will post the link in the comment section. And there's one quote that's not from the movie, but from the person Cary Grant. This is a quote: "Everyone wants to be Cary Grant, even I want to be Cary Grant." That was today's video about the chemical element arsenic. Thank you for watching. Have a nice day. Bye bye.